Okay, this is Todd with Talk Time AI. And in this video, we'll be talking about our process and systems to develop production ready softwares for businesses, primarily using artificial intelligence as the driver to help small and medium businesses thrive, compete, to get more jobs done, to reduce labor costs, to redeploy labor across their organization in areas where it can provide more valuable more value to the company. And the things that we'll be doing will be kind of eliminating the mundane work that's what these softwares do, the mundane work, so that your team members can focus on more valuable things within your business. So this video is going to tell you specifically how we do what we do, the outputs that it provides, and how it all works. We're also going to talk about the process for how a business obtains access to systems like this, how simple it is, how fast it is, the ROI that it will provide, and what you need to provide, what access does our system need in order to provide this value. So we're going to go through a couple of different presentations. I'm going to show you some good information. This is going to be a really good video and in-depth recording. So ultimately, right off the top, what we're doing here is we are um, helping primarily manufacturers and small and medium-sized businesses, whether it's on the shop floor or in an admin sense. We want to help them resolve efficiency breakdowns in their operations and administration. So the first thing we're going to do is identify how we're helping companies find hidden costs. We're going to identify the gap that we fill. We're going to give a couple of use cases. So we show some examples. Later on, I'm going to show you actually access to some of these systems as examples. We're going to go ahead and start with kind of the basic premise. So the hidden cost isn't the price that you would pay for the technology itself. It's the labor, confusion, and bandwidth restrictions in your business. So if your processes are either confusing, if they are very manually driven, you've got spreadsheets maintained by hand, you've got people information stuck in people's heads, you're doing high volume repetitive tasks over and over and over again, that's when you're going to come up with inconsistent outcomes, slower response times, and increased operational error and risk. So leaders kind of get stuck in the middle. You're aware that you have a problem, but you're unable to justify the time, cost, or risk required to fix it. And in those results, also, you're going to be taking too long to do these things. So, for example, if you've got a business that relies on getting out quotes, right, as opposed to taking 8 weeks to get out a quote, if you could do it in 8 days, right, how many more quotes could you provide? And even with a very conservative win rate on those, if you could turn up the number of quotes by 60% and only win 8 or 9%, if each job is worth $30,000 to $50,000, that's significant revenue for much less work. So the gap that we fill is between inefficiency and costly six-figure software. People think, and rightfully so, that if you go the traditional route and you hire a company that is reliant on humans to do all the programming, that, and we'll do some of this math in a bit, but essentially, if you have three people and you're going to take 6 months, senior software engineers, 6 months to do a job, which is exactly how long many of these take, if not more. So conservatively, 6 months, $175 an hour, which is also on the low end of a senior software engineer. Three people for 6 months at $175 an hour is roughly $500,000. And that's why a lot of these small and medium-sized businesses aren't engaging with these types of projects. So what we do is we are all about providing systems at a more affordable price point. We'll show you how we do that, removing the repetitive rules-based work so experienced employees can focus on judgment, decisions, and revenue-generating activity. We integrate smart systems to handle high volume, repeatable tasks in your business where your people are doing the same thing over and over. If that happens, if that's what they're doing, it's like data entry. Maybe people are doing data entry into multiple systems, or they're doing it, 4 to 5, 6 hours per day, just doing data entry. Maybe you've got humans handling. We want humans rather to handle the nuance, the approvals, and decisions as opposed to the grunt. Let the systems do the grunt. The humans are more valuable than that. And then this process becomes consistent because whereas you're going to find errors with people that are doing the same task over and over and over again, The systems are rules-based, so they don't make those errors. They don't get tired. They don't have bad days, and the results become consistent, measurable, and auditable. It eliminates tribal knowledge dependency, where you have knowledge stuck in people's heads. It eliminates delays and errors because the work is done so much faster. The access to insights and results are so much faster. And then the inconsistent decision making will be severely reduced because you're going to have access to the right data more often and much more quickly. The impact, speed, and efficiency of the outputs, as well as accuracy. You're going to have clear accountability because you'll be able to see exactly where the information comes from, and those outcomes will become so much more predictable. So let's use an inventory management use case. In this case, we have a situation where um, client was it was in a like a block business, so they make cinder blocks, and his process was that he would manually drive around his 16-acre lot, and where he would find a patch of land where there used to be pallets of a certain type of cinder block, a certain size, color, what have you, shape, he would make or buy more. In his case, he has roughly 100. And again, this is just an example to share with you, especially as we make the infographics. But as an example, what would happen is um, he would, well, actually, not this is an example, but in his case, he has about $1.5 million in inventory, and he knows he's about a half million heavy, but he doesn't know where. So in his case, what was happening is that he would have 50,000 units, say it's January now, 50,000 units of something that he might not sell until August. So we've got cash tied up, line of credit tied up, interest payments on that line of credit tied up. Similarly, he might have no units of something that he might sell 30 days from now. He might sell 20,000 units of it. He's not ready, so he'll miss an opportunity. And the system is designed to solve that problem. So as opposed to him driving around his lot and no one else is really doing any of this work, he's able to have access to insights immediately so that he doesn't miss any um, opportunities. We've got access to his ERP. We're connecting our system to his ERP. We've got 8 years worth of data. So we'll get to know obviously the aggregate, the averages, but also the growth patterns of each product along the way for the last 8 years to be able to properly forecast using detailed algorithms exactly how much inventory he should have on hand so that he never misses an opportunity, but he's not wasting money along the way. Similarly, he'll be able to know not to have too much, right? So he'll be able to pare back. So in his particular case, he will have no more manual inventory guessing. He'll have instant access to accurate inventory forecasts, no more spending on overstock, no more missed sales. He will reduce his inventory on hand spend from 1 million to roughly, I'm sorry, 1.5 million to 500,000 or to 1 million. So he'll reduce his overall inventory spend by $500,000, which is also going to equate to $40,000 in annual interest not spent. He's going to accomplish this in 10 months. So in his case, he is his system cost is, again, this is real, but again, for an example, he spent $50,000, and he will claw back in 10 months $500,000 because of the inventory that he doesn't have on hand that he doesn't need. He'll be prepared 60 days in advance to get ready for sales that he'll have 60 days out, but he doesn't have to have that inventory in hand for 10, 11 months while he's waiting for, say, next October to come around. The next example that we'll give project command use case or project command center. This is use case number 2. So this is an um, electrical distributor. So they put industrial or commercial size electrical systems in, um, whether it's Home Depot or data centers or what have you. So they had a series of problems. One of the first problems that they would have is, so critical expertise lives in individuals' heads, right? They've got bottlenecks, single points of failure. The data lives everywhere. It's a constant and multiple re-entry across systems. They have what they call a cross-reference problem. The team is spending hours and hours manually matching competitor parts to their parts as they're redoing, existing systems into new systems. These sometimes these spreadsheets that they're going through are 500 or 600 line items, and it's just valuable time from high valuable people going through spreadsheets to find 1 or 2 line items. That's not a good use of their time. And this problem is leading to quotes taking 8 to 10 weeks to produce, like I mentioned earlier. They're able to bid fewer jobs. The research is manual and slow, and there's no status visibility amongst the team, whether it's sales or operations, quoting department, accounting, is exactly the status of a lot of either work that they've already done or new quotes going out. So what we put together is a project command center. It's got multiple phases, starting with the most basic CRM, but we're providing them a unified dashboard. So views for sales, engineering, operations, and management, mobile responsive access for field access, so real-time notifications and alerts. So we're going to automate several things. We're going to have automatic document reading. So as again, this is real, but it's just an example to prove the point of what these systems do or can do. It can do whatever it is that you need it to. In this case, as they get RFQs and requests for quote, they'll have the AI read the quote, parse read the request, parse the request into pieces that are relevant to them. They are going to be able to do all their cross-referencing automatically, right? They're going to automate that quote generation for human review. So human in the loop is what we call our system. It's called human in the loop. And again, we're with TalkTime AI. Human in the Loop is the system that we've developed and we use. So they're able to have much more efficient quote lifecycle management, knowledgeable extraction and search, so they can, basically have an AI assistant that's trained on their data, and they can ask it anything about any quote or any job that they've done in the past. They're automatically able to pull pricing availability from vendors and contractors to generate these quotes. It's going to sync up the customer data with the CRM automatically. So we've eliminated all that multiple dual entry. So what was the impact? Just on the extra quote time, we're saving a little over $70,000 for this company. And the quote came, they're a fast 25% faster at minimum. And that is a very, very conservative estimate. But again, we don't want the numbers to seem unrealistic. So we use 25%, even though the reality is it's higher. 45% fewer requotes because they don't age or expire. 20% more opportunities, right? Because even if they're able to get out quotes much faster, we're going to say we've got a very conservative win rate, and the capacity to get these jobs out faster for them means that an extra $325 to $650,000 of revenue each and every year. When we look at exactly what the system is that we use. So what is human in the loop, and how does it actually produce softwares that make some sense? So human in the loop is a completely autonomous development factory with 19 specialized AI agents that handle everything from development to deployment. That means your jobs are coming out, or your softwares are coming out 90% faster. So it's 8 weeks instead of 8 months, and 80% less expensive. So I know it's right to be skeptical, but here's the reality. A problem with traditional system development is part of it is time, part of it is money. So there's lengthy discovery to learn the problem. You've got 46 months of development, potentially, if not more. Again, that's on the conservative side. You're waiting for the client and quality reviews over and over. You're waiting for deployment to occur. You're waiting for the fixes to be done, and then the money at $150 to $800 an hour. And again, I use $175 an hour as kind of a placeholder there. You're looking at easy $200,000 to $500,000 engagements for enterprise systems with enterprise level value. It's slow, it's expensive, and frankly, it's out of reach for many small and mid-sized businesses. So we asked a simple question: what if AI could do 95% of the development work that's repetitive? And this is critically important. What if AI could do 95% of the development work that's repetitive, while humans focus on the 5% that actually matters, which is understanding the client? So here's what our system actually does. So the client, you tell us in a conversation, and we will transcribe the conversation, what you actually want, right? What problems do you want it to solve? What are your current pain points? What do you wish you had in a system that you currently don't have? So here's a look at some of the agents that we put to work. So we have agents that do requirements. So understanding what you actually need, research, finding the right tech stack for your use case, architecture, designs complete systems, not just a user interface. The builder writes full stack code with tests. And all of these are their names. So Quinn does the requirements. It understands what you actually need. Scout does the research, finds the right tech stack for your use case. And we are proficient in any of the large models. We can build our own models. We're not limited by any one software. We're going to do the right thing to accomplish your goal. Charlie is the architect, designs complete systems, not just a user interface. Atlas, he's the builder, writes full stack code with tests. Ward does quality, so he scores security, performance, and completeness. Maverick, the enforcer, rejects anything with placeholders or to-dos or incomplete work. Devin, the debugger, fixes issues automatically. Clara does visual QA, so validates UI all three type screen sizes: phone, tablet, and computer or desktop. Octavia does deployment, commits to the GitHub, ready to deploy. Each agent specialized and optimized for one job. So, for example, Maverick doesn't negotiate. If it's incomplete, it is rejected. So the client, you get a production-ready application with full source code, tests, and documentation, all deployment ready. The time elapsed to proof of concept is usually 4 to 6 business days, depending on the complexity. So what are our protocols? The first thing is automatic knowledge capture. When an agent solves a problem, it will give a command to remember this to the rest of the system, or always do it this way. So Loop automatically recaptures or automatically captures that learning to a structured knowledge database. Then we have the session memory protocol. Each section starts with Loop reading. So critical rules for your project, past learnings and solved problems, current work context, patterns and conversations. And the AI literally does its homework before writing any code. Now, I know you're thinking Replit and Lovable and things like that, and this isn't even in the same ballpark. And I'm going to break that down a little further in a little bit. But then we're going to have an error prevention database. So every bug fixed gets tagged with its production pattern. So in the last 3 months, just as an example, we've seen 150 errors and we prevented 60% of the bugs before they were even written. Then we're going to have the cross-project learning, which is amazing, the water cooler protocol. So imagine standing at your water cooler in your office and someone says, "Hey, I solved this problem," and you're telling everybody else about it because you're really excited. Well, this system does the same thing. We say as the agents share amongst themselves so that they can all learn. So these valuable learnings get promoted to a shared knowledge database. And so a CSS gotcha discovered in project A automatically helps project B, C, and D. So let's look at the speed then. The 4-week MVP is, why is that so fast? Well, the first thing is we have parallel agent execution. So for example, while Quinn is refining requirements, Scout's already researching, while Charlie is architecting, Artless is warming up. The agents work in parallel wherever possible. And if you only have 2 or 3 people working on a project, they can't do 9 different things at once. Our systems can. So we have no human bottlenecks. Traditional development, you have developer writes the code, then waits for the review, then fixes, then comments, then waits for QA, then fixes bugs, then waits for deployment approval. Well, Loop, we build automated quality check, automated fix, and then we ship. There's no waiting for the human. So the human developer, they're going to juggle Slack, meetings, emails, multiple projects. How much work was actually getting done in a given day is limited by all the meetings and emails and things like that. Loop's agents only have one job, and they execute it with 100% focus. So what's the real world impacts? Traditional software engineers, let's just say, again, you've got the 2 to 3 engineers or consultants, you've got $150 to $175 an hour, 4 to 6 months to deploy, typical exposure, 250 to 500,000 before you've got a meaningful system that can start even thinking about producing meaningful ROI. Whereas the AI-driven development, we've removed 89% of that labor from the process. We've got weeks, not months to deploy, less overhead, less error, typical exposure, 25 to 75,000 before meaningful ROI. It's not even close. So we're again, like I'm showing you here, we are cutting out 80% of the cost right off the top. So our systems are focused on margin improvement for your business and your productivity, right? And we're able to do it quickly, both in time and money, because those are the two real problems. Perfectly suited for budgets and needs of small and mid-sized business, particularly manufacturing businesses. The math is really simple. When you remove 80 to 90% of the cost and time, we pass those savings to the clients while maintaining fair margins on our end. So, and this is not a you get what you pay for type of discount. So the clients get the same or better code quality enforced by our Loop protocols. You get full test coverage. It's automated and it's not optional. Again, it's rejected if it doesn't meet the standard. Complete documentation generated automatically. Production ready deployment, which we'll define that in a bit. I know people use that word production ready and it's really not, but we'll show you what that actually means. And it's included standard and it's non-negotiable. We've got visual quality assurance at 3 different screen sizes, verified, not assumed, private, GitHub repo with full source. Client owns everything. The only thing you don't get is an 8-month wait and weekly status meetings. So think of this like history repeating itself with Loop. This is kind of the Blockbuster versus Netflix. Uh, Blockbuster, their model had physical constraints and limited by the number of stores. In this case, in the software world, limited by the number of developers. You've got high fixed costs, slow delivery, and all of that. So Netflix right? Obviously, there's no physical constraints. You can be anywhere. So in the case of software development, AI agents have unlimited capacity, 80% reduced marginal cost, instant delivery, hours, not months, consistent quality. You've got protocols enforcing standards every time, effortless scaling, whether it's 10 projects or 1,000 projects, it's the same infrastructure, client experience, real-time progress, Slack notifications, and visual proof. If you recall, Blockbuster had the chance to buy Netflix and they passed. And history is repeating itself. People are making the same mistakes. Whereas with Loop, we're able to do this so much faster. Okay, so let's talk a little bit more on the technical side. Now, we already know that the software engineers are expensive and slow versus our AI protocols. So you might think, what about Replit and Lovable and things like that? Now, here's the issue. Most of these AI builders are optimized for speed and visual output, not correctness, architecture, or long-term reliability. They're designed to hook users with a fast, pretty demo. They create the illusion of progress. You get clickable prototype quickly, which is awesome, but they fail at the real system design because they start up front and they don't really build what you need in the back end. So most AI builders do the user interface first, right? As opposed, and then do the systems last. And the real systems need to do that in the exact opposite order, right? So let's just call it out. These systems, so Lovable and Replit, they're really good at the front end interface, but it's interface versus an operating system. And what you need are operating systems with a user-friendly interface, not a user-friendly interface that doesn't have the operating system behind it, right? So, and in reality, a lot of their interfaces are just they're putting a pretty wrapper on top of Claude CLI. So we've got an orchestrated development operating system. So they have no agents, we have 19 agents. They have no enforcement, we have the rapid AI development protocols. They don't have memory, we have the recall loop. Again, they forget, and we're going to touch on that in a minute. So they don't have a quality assurance loop. We have a mandatory quality assurance loop. No deployment. We have a GitHub delivery mechanism. And then again, the session memory recall. And memory, when you're developing systems, has to be institutional, not just convenient. This is not chat memory. This is institutional engineering memory stored inside the project itself. So Lovable and Replit, they might help you write code faster. Loop prevents you from shipping broken systems at all, let alone faster. So how do we rise above? So first thing is the technical blueprints. Think of it like this. Let's just say you came to me and asked me to build you a kitchen. You give me your cabinets and you say, hey, I want you to build this cabinet and I want, it to look, here's my countertops and all that. And then we go and build it. And I call you and you come and you take a look and you're happy with the way things are looking, but you say, hey, Todd, I gave you, the cabinets, but where does my fridge go? Where's my stove go? How about my dishwasher? I'm like, hey, wait, you didn't give me all of that. All you gave me were the cabinets. You didn't give me, you didn't tell me we need to do that. So we don't have plumbing, we don't have electrical, we don't have gas where your stove needs to go. We don't have any of that. So you don't get those things because they weren't part of the initial engineering. So the technical blueprints that is developed by Loop is exactly where we solve the infrastructure problem. We get that right. And we put the amazing visuals on top, not the other way around. The next thing is that people don't understand that AI, including Lovable and Replit, because it's Claude based, they have context window limits. So the big AI models, they offer you very limited memory. So their build experience starts essentially at a junior software engineer every single time. It'll never be a senior software engineer because it doesn't remember. Loop documents your project progress, so it always makes progress. It never wastes your time and recalls your priorities. It's got tunnel vision. Other builders can only look at the file that it's working on, meaning it's making changes to a file, but doesn't really realize that that change affects and breaks other things down the line in the software. Our system Loop is looking at what the effect that this change will have on every element of the software. So it automatically analyzes each possible change and the effect it'll have on down the line. And then lastly, AI is helpful to a fault. They'll go off on a task and see an opportunity to fix and optimize something else, which is good, but they'll do partial work with no documentation, creating these Easter egg bugs that never really show up until it's too late. Too late. We've certainly tested this and we've asked these systems, so where did this bug come from? Who did the code? And the system says, I don't know. What do you mean you don't know? It's only you and me here, you and me, the AI, like you had to do it. I know I didn't write the code, so you had to write the code. And it doesn't remember because it didn't document it. And the loop agents are each only focused on their one job and document all analysis and progress for future reference. Loop is fundamentally different because you get a complete workflow, not just code generation. We don't just write code, it's complete workflow. So it's discovery, it's requirements, proposal, agreement, blueprint, build, test, deploy, and deliver. And what's the result? With other tools, you're going to get a primarily attractive wrapper, right, on a Claude Code CLI. Here's the code, good luck. Loop, here's your working application working on GitHub with all the tech tests passing along the way. We've got multi-dimensional quality scoring. So each build is scored across 5 dimensions: security at 25%, performance at 15%, RAD compliance at 25%, code quality 15%, visual quality 20%, where RAD is the rapid AI development. So we've got we're going to look at the load times, the database inquiries while we're looking at performance, no shortcuts, complete, or we've got fully complete implementation and RAD compliance, code quality, clean code, error handling, and that code quality review, and then visual quality, responsive design, and accessible. And it has to have at least 85% to pass, and it's rejected until it meets that mark. This is going to be real research, not hallucinated best practices. Loop Scout Agents uses CLI, MCP, and or APIs to research the current best practices in real time. So unlike the big LLMs, Loop doesn't hallucinate on a tech stack from 2021 training data. It researches what's actually working today and provides actual citations. And then the visual validation, Loop's Clara agent tracks or takes screenshots of the systems and runs simulations on screen just like a human would at 3 viewpoints: mobile, tablet, and desktop during every single build. The system validates that the UI actually looks right, not just write code that complies. So Loop users get production ready applications they can deploy immediately. Now, what's important too is the recall loop. So whether with other development tools, every time you start a conversation with an AI coding assistant, you're starting from zero. It just doesn't know your project's architecture. It doesn't know the bugs you fixed last week. It doesn't know your team's coding patterns. It doesn't know that one API quirk that took 3 hours to figure out. They have amnesia. Every session they forget. So again, you're starting at that junior engineer. Our proprietary recall loop is an integral part of this system. It's a self-documenting, self-learning knowledge system that transforms AI from a forgetful junior developer into a domain expert that gets smarter each and every session. So how do we do it? We do automatic knowledge capture. So when an agent solves a problem, it'll give a command to remember this or always do it this way. We capture that learning to a structured knowledge base, not in some cloud server, it's locally right on your project. And then the session memory protocol. Every session starts with Loop reading the critical rules for your project, past learnings and solve problems, current work context, patterns and conventions. That this is not something that is part of Lovable and Replit. So the AI literally does its homework before writing any code at all. And again, we talked about that water cooler protocol. So no other system learns and improves on your specific project. So ChatGPT and Claude, the same capabilities, whether it's your first day or your 100th day. Copilot, it's autocomplete based on general patterns, not your patterns. Other AI builders, again, they start fresh each and every time. We're taking valuable learnings to get to promote it to a shared knowledge base. A CSS gotcha, discovering a project automatically helps project B, C, and D. So what does production ready actually mean? When we deliver an MVP, so minimum viable product, you're going to get a full stack application, front end and back end, plus database, user authentication and authorization, complete error handling. You're going to get unit tests, integration tests, E2E tests with 80% coverage. You're going to get responsive design, again, verified with screenshots and testing, API documentation. You're going to get deployment configuration. You're going to get README with setup instructions. Other tools are going to give you a starting point. We're going to give you the finish line. So when we have a conversation with a prospect that wants a problem to be solved, then we can definitely get that done. So we'll have a conversation. We're going to document and transcribe. The first step along the way is actually going to be what we call a V1 ideation, right? So we're going to transcribe that conversation. We're going to pick out all the needs, the problem that we heard, and then we're going to go back and do research using our loop system to propose systems to solve specifically the problems that were discussed during the call. And so I will be able to provide a full breakdown of exactly what problems we're going to solve in the proposed software, the phases that we'll use to build, in terms of time, to build a system, the specific tools, tech stack that we're going to use. We will forecast your ROI as part of that V1 ideation, because we need to know that the system is actually saving you time, money, or both, and creating more capacity for you to do more work inside of your business. We'll have a second call. We will then confirm that our V1 ideation is correct. We'll make any corrections that are necessary. Then we'll complete a proposal. So that proposal will give you an executive summary. We'll break down exactly, again, reminding ourselves what problems we're solving, the business impact that we are providing, right? We're going to define exactly what the system is, how it changes your work, right? We're going to define it versus today versus with the system. We're going to show you what impact we're going to be able to have in both time saved, money saved, additional revenue, whatever the case might be with this specific system. In this case, I'm looking at an example proposal of a quoting engine, very similar to the one that I showed you previously. We're going to show you exactly what it will do for you. We will give you a full calendar development schedule, the phase breakdown, when we're going to build what, how long, and cost, for example, how the pricing works, the terms, the investment, all of those things, the ROI, again, the projections, the financial impact that the system will provide. We are not selling systems to sell systems. It has to provide you a real benefit to your business, or it's not even really worth talking about. So how does the system work? So here is a visual of of the system itself. So let's just go through a couple of examples. I need software built, right? We're going to let the system take us on a quick test drive. So we're going to take it for a test drive. I'm going to solve a problem with software. So let's just say we're in the automotive space, okay? Because it's going to ask us, what space are you in? Because again, these problems can be solved no matter what industry you're in. So whether you're in healthcare, legal, automotive, etc. I need help with it. I've got various choices. Let's just say I want to do, again, quote management, right? Let's continue. I want software that matches our process. It simplifies our workflow and has AI capabilities. Again, these are all things that we can incorporate. And this demo that we've got for you to be able to experience, we'll go ahead and let's say that our team has 6 to 15 people, and it will create a system live for you. We're going to say enter your company name. We're going to say Nestor, just as an example. We're going to build a prototype, and we're going to be able to see it, right? Because it's designed to be custom, and we're going to come up see exactly what kind of system it's going to give us. All right, here we go. So this is what a quote builder might look like. Again, just to provide some inspiration. All these systems can be built inside of the Loop experience. So let's just maybe take one more test drive. Let's just say this time we want to do, well, we're going to solve a problem with software. We'll stay with automotive, right? Let's say that we want to do, what do we want to do? Let's do inventory management this time, right? And we're going to do something that integrates everything in one place and works on mobile. That is our, so 6 to 15 people. And what's the name of our company? We're going to do Scion Steel in this case. Okay, and it'll build the system again. So let's see what we're taking a quick look here. Again, here we go. It's just a system. So that it will actually build out an inventory-based system, but it could be really anything. So maybe it's you want a quote builder. We kind of looked at that already. Maybe it's time and billing, right? So what does a time and billing system look like? Boom, there you go. Um, what if we wanted a partner deal room? You've got to keep track of your relationships in the partner deal room. There you go. Everything is available, and we can customize these to your needs. I want to give you an example. Actually want to show you the system that we were talking about in that quote generation, the system intelligence area. Here, let's go ahead and let's see if we can get to this system. while that one's loading, we're going to look at another one. I want to show you exactly how fast some of these things are being built. This is a system called Aurora that was built by Loop. The Aurora does investment grade intelligence research. This is producing products, research, analysis, and insights that would be to the level of what a McKinsey or a Bain would provide. And instead of charging $500,000 and 8 months, much just fractions of that cost and done in 90 minutes. This isn't so M&A and private equity use this tool to research. So you just put in your URL. In this case, it's all custom. And what systems are we using here to be our lens to determine, okay, I need to use the information that's in these systems against it. It will do 99% accurate research on out on the internet. And what a little known secret is LLMs really are only about 40 to 60% accurate when it comes to open web research. You actually target it by industry, by product type. And so, for example, if we look at the outcome, we've got, again, this is investment grade intelligence. This system, the Aurora system, was built in 12 days. Insane, absolutely insane. So I know everything about this company. I know the opportunities to work with this company. I know all of their competitors, what they're good at, a complete SWOT analysis, et cetera. All the opportunities, again, based on 99% intelligence, because we have a protocol that transforms each and every website that we work with into 99% AI consumable information, because AI cannot read the internet like you think that it can. So that was built in 12 days. This is the start of the operations intelligence system. So this is a dashboard that we're looking at. Essentially, this is a CRM, so it's really just their foundation. We can look at accounts, all of their accounts. We can look at all their contacts. We can look at their opportunities along the way. So for example, in the accounts, if we just look at any account here, we can see everything about that account, even a relationship tree, because they might have multiple contractors, vendors, distributors, all associated with one opportunity, and they need to see that visually. So that everything is looking good along the way. They even wanted certain reporting so that they know which distributors or vendors are actually winning jobs and performing, so they need to be rated against one another. So and again, this system was actually built in 5 days. We're a couple of weeks in because, clients, they need time to review to make sure that they like it, and we make the appropriate adjustments. But ultimately, what we want to do is, in this video, make clear what Loop does. What Loop does is takes your requirements based on you just telling it verbally, and even with some screenshots of your current system, and it will allow us to be able to put together a plan based on your pain points, objectives. What would you like the system to be able to do? Help you forecast what the system can look like, what it can actually accomplish, and the benefits that it will bring to your organization. And we'll be able to tell you exactly how quickly we can do that. And again, at roughly 80 to 90% less cost, with 80 to 90% less time to deliver. And as far as access to the systems that we would need, it really just depends on what you what systems you have. So sometimes if you're behind a 2FA, a two-factor authentication, then yes, you'd have to show us that so the system can get in and take a look. But otherwise, we don't need often too much. If we are integrating into your system, we will work with you to get access to any needed APIs that are required. And yeah, I mean, that's pretty much that. So let me know if you have any questions. This is telling you all about Loop.